thermal imager. And the thermal imager we're going to be taking a look live at in a second. This thermal imager we'll be using from General, the GTi10. This thermal imager is pretty neat for a lot of different things. In fact, if you look at some of our webcasts, we've used it on electrical problems. Also, Motorage, this month, if I'm not mistaken, they issued
There's thermal imaging by Tony Martin.
Tony Martin, Tony has checked it, definitely checked it out. So let's bring this over to the vehicle. What you're looking at is actually the condenser through the Jeep. Let me focus it here. You can see that orange color in the background, the little pipe on the bottom, and maybe Keith, if you get on that other side and maybe point to some stuff. The lighter the color, no, I meant on this one. The lighter the color, you see like that orange block? That is actually a hot spot. When I move it over, you can see the end of the condenser, the orange looking, yellow looking lines.
Notice how this is changing here. The fan is cycling, the pressure is cycling on and off. Now it's on. So now you see that hot refrigerant being passed through the condenser. Okay, that's that heat being released to the air. It's now off. You can see how it's cooling down. Do you think you might be able to find this line or restriction in the condenser really easy?
Oh, really
like
easy.
this?
You know, the nice thing here, Pete, you can see in the upper left-hand corner of our picture, when it does go off, that starts turning into a purple color. And what I need to do here is maybe have someone turn the AC to max. So turn it on to max AC here and try to leave it on.
Oh, I have it set up on max. That's why it's cycling. You can see how it changed. Now we're doing
Now
this
look
so that you can see the temperature change.
Look what's happening right there. That's a big temperature change than just what we had a couple of minutes ago. You can see that this is getting a lot warmer, taking the heat out from the vehicle. And if we had a clog in this condenser, you can see it's almost all red. Here, shut the AC off for a second. Okay, now the AC is off. Give it a few seconds and watch the color start to go more into a darker color. There we go. See the dark color, a purple? Here, put it back on. Okay, now the compressor's coming on. Watch the red come in. If we had a clogged condenser, you could see actually the lines load. You can see the lines coming right through.
If you can see what we can see, if you can see it clearly on the screen, you can actually see the coolant rods in the condenser.
Yeah.
There's bright yellow stripes lined across the screen. You can actually, I don't know if you can see it on the webcam, you can actually see the line, on the condenser assembly.
So right there, that's really neat where you can see that. Now the other thing it could be used on is the orifice tube. Here it is, you can see the hot side on the orifice tube. Okay, so here again, for you guys that didn't see it, if you look at the very bright yellow, you can see like little lines, there's purple bars. That is actually the grille of the Jeep. But in the background, Pete, I need you to point to that again, the yellow lines. Let it keep by. Oh, there we go.
See? Right, yellow lines going across.
And now if we turn the AC off, so now watch what happens. You're going to see the yellow lines start to disappear. Compressor's off. We still got the heat from the inside of the vehicle being transferred out to the condenser. And notice now it's starting to get a darker color. And by the way, on the spectrum scale, the lighter the color, the hotter it is. So now you start to see it's turning. Oh, there we go.
Now look at that.
Okay, now it's totally off. You see it's all purple. Pete, put it on. Okay, now you can hear the clutch went on. You can start to see the purple is getting lighter. It's going to go. You can start to see the tubes. It looks like an orange, purple-orange color. And now it's going to turn into a bright, like yellow type of color, or white color. Sorry about the unsteady hand here. So what is this used for? Basically, this is a very good tool to use to see if there are any problems in the condenser, any clogs. You can also, I'm going to show you what an alternator looks like. Not that we're doing alternators, but you can see how hot that alternator actually is.
Hey guys, it's thermal imaging. As you're reading the article, this is a fairly new diagnostic process. I know guys on GTi10 actually played around with this a few years back, but the cost of the tools is getting to the point where they're more affordable. There's so much that you can do with thermal imaging. And again, the article that Tony put together gives some great examples. What if you wanted to look for a misfiring cylinder? You know, if I can get that imager on the manifold, I'll see the cooler cylinder. If I want to check condenser or radiator for restrictions, if I want to see which hub bearing is bad, by looking at which one's hotter, anything that you can do with the IR thermometer, think of it this way. The IR thermometer is the multimeter. This is the lab scope of thermal imaging. And I think there's going to be a lot of techniques that as more guys get to try these and put them to work in the field, you know, you're going to find a lot more uses for them. But yes, there is a learning curve, especially with a device like this one. And I'm going to mess this word up. I apologize in advance. It's called emissivity.
Actually, you got it right.
Okay.
Emissivity.
So I got
different things emit different IR wavelengths at the same temperature.
Yes.
So you have to know what you're measuring.
But the rule of thumb is if you're trying to measure a nice shiny aluminum line, that's going to measure differently than a flat hose or the condenser that you saw
And
earlier.
basically what I have this on right now is the orifice tube.
Yeah, notice real closely, on the right side of the picture, that's the high pressure line coming into the orifice, and on the left is where it's passing through. What happens at the orifice tube? The pressure drops and the temperature drops, and you're seeing it right there for yourself. Now imagine you're looking for a line restriction, and you're going down the line and you see that. Guess what? You just found your restriction.
Could I use thermal imaging to find an AC leak?
You know, you know, if you were doing an AC leak, that would be an interesting experiment. Because if that gas is passing enough to cause a temperature drop, you might.
This being something new, as new things come out, you got to play with them and you got to document them.
Yeah.
Now look at the orifice tube right now with the air condition off.
Right? Nothing's flowing.
Nothing's flowing. Alex, put it on. Watch the change as the refrigerant. So this is a great test to see if the orifice tube is actually working. Is it clogged rather than you cutting it open? So keep looking at it. You're going to notice that the color is changing. Remember, the lighter the color, the hotter it is. And there you go. Look at it. All the way to what side of the screen, Pete?
127 over there.
Well, what side is the hot side?
Hot side on the right. Yeah, hot side's on the right. You can see it really bright yellow. The temperature graph all over the right of the screen. You know, almost white, the hottest point, dark blue, black.
So this is a neat tool. And by the way, for electrical problems, catalytic converters, and one nice thing here about the general tool, they have them in different temperature ranges, even up to over 1,000 C, which is good enough to do most catalytic converter things.
What would a partially charged system look like?
Well, again, what would a partially charged system look like? Most likely all those fins that we've seen turning the bright yellow color, most likely would not, I would think. But we would have to play with that. This is something...
And like I said, we're both kind of new to this tool ourselves. There is a way that you can set the temperature range. If you notice on the scale on the right, it went from this number on high point to this number on the low point. And I'm sure that there's an adjustment on the tool, and the good folks in general, I'm sure, can tell us. But I'm sure there's a way to adjust that band down. Let's say that I wanted to look for a temperature change from the condenser. What's normal from top to bottom? About 40 degrees?
Right.
So if I set that range up, I could use that to scan across to see how it flows through the condenser more accurately. Right. This is like, you know, and what I told folks before. Remember, older guys, remember the first time you saw a fuel pump current pattern on an old choppy flute scope? You know, and you went, wow, that's just the neatest thing since sliced bread. Well, now it's kind of a common troubleshooting procedure for most of us. That's what thermal imaging is here.
And in fact, it takes years of testing. Talking about that, Don Schnell, when we did the ATTACS program, the AMPS current program, we did hundreds of cars, and it took over a year or so of study with a bunch of different people that we all had the same amp clamp, same lab scope, to justify saying, this is good, this is a known good, this is a known bad.
Right.
What I would suggest with something like this, we would have to put an air conditioning machine there, remove half the charge, see what it looks like, then fully charge it, totally discharge it, and then see what the difference
Well,
is.
the neat thing too is this particular tool allows you to take a camera image,
Oh, right.
right, and keep that image as a reference. So, you know, if you have that and you were learning how to use that tool, you got a car in with a problem, you take a few pictures,
Yeah,
right?
but
You diagnose it.
yeah, we should tell everyone this has a mini SD
SD
card. So these pictures, I just take them and put them right on my computer, and bingo. This is something you can show your customer and prove, I gotta cut that line open for that orifice tube. This is your problem, why the vehicle is not getting cold.
Yep.
It justifies things, but it is a learning curve.
What's the price on the tool?
Oh boy, you know, I don't remember off the top of my head. I would say it's somewhere, and again, just a ballpark range of about $1,900, depending on the temperature range you get.
Yeah. Probably about the same as an intermediate scan tool,
Yeah.
right?
But again, the difference here, you know, is anything like this, and this is a great tool, but this is more of a thermo temperature gun. It is not it's a thermometer more so.
Right.
This is a thermal imager. So it's like the old graphometer, like you said, and here's the lab scope.
Oh, this is not even graphing, that's like just plain old multimeter.
Yeah, well, multimeter type thing. This is the way to go. By the way, you want to see a real window defroster that's not working right?
Yeah.
Boom, this thing is
Imagine
perfect.
seeing that.